Dear participants, let us move forward with experiment number 13, section 1 IAVOC 305. In this experiment, we will be looking forward to control a DC servo motor with Uno board, and our further objective will be to control the rotation of the servo motor with the help of a potentiometer. That means we will be interfacing a potentiometer and a servo motor. We will be a micro type servo to the Uno, and rotation of the servo will closely follow the rotation of the potentiometer. The equipment and components that are required apart from this laptop or desktop, whatever you use, Uno board and USB cable, you need a continuous rotation micro servo. Here we have used this SG90. You need a trim pot, or you can use a potentiometer as well of 10 kilo ohm, and you need some jumper wires. You see, although we have covered necessary theoretical background on our lectures, but still I will have a brief discussion on the same. You see that servo is quite a generic term. Okay, it signifies a closed loop control system. It can be connected to any actuator, definitely, and here we are concerned with a motor. So the servo mechanism, it's a mechanism, will be connected to the shaft of the motor. And you see, whenever we are talking of much sophisticated servo units that are used in industrial robots, they can give you feedback about acceleration, position and velocity of the motor. But here in this case, we are not using that sophisticated motor, and DC servo motor that we are using in our case, we will be having only position feedback. Okay, so let us now try to understand this block diagram. From the microcontroller side, we can use anything. We can use an Arduino microcontroller, we can use some microprocessor, whatever it is. From that side, we need to give a position command. We need to give a position command. Now, whatever command we give in the servo control unit, that command has to be given in terms of some voltage. So if I say that rotate the servo by maybe 75 degree, so we have to apply a proportional voltage to the servo control unit. Okay, now see that servo unit accordingly determines the current that has to be supplied to the motor. Now see here one thing, that this position command is not the only parameter that the servo control unit will be considering. It will also consider a position feedback signal from the motor, because if you have asked the motor to have a rotation of 0 to 75 degree, but actually the motor is maybe, for a typical case, it may so happen that the motor is already at 42 degree position. So accordingly, a position feedback will be coming to the servo control unit. Now see, this position feedback again will be nothing but a voltage. Now this command voltage and this position feedback voltage, they will be finally mathematically compared within the servo control unit, and finally the motor gets the drive current of a particular amplitude for a duration. So this is the very basic servo mechanism that you can see in front of you. Now you see here, I had already shown you the internal construction of a DC servo motor in our theory lecture, but here you can see this diagram again. We are indebted to lastminuteengineers.com from which we have taken this diagram. And I must tell you that you all visit this lastminuteengineers.com. They have given very good coverage of each and every sensor or actuator that you can interface with an Arduino Uno. You will be really benefited. Now you see here that here actually there is a DC motor, there is a potentiometer you can see, and a control circuitry that we have. Now you can find shaft of the motor is mechanically coupled with the pot. Now whenever the pot is rotated, the pot never rotates by itself definitely. When the motor rotates, then the pot is rotated. Now when the pot is rotated, a proportional voltage is generated, and therefrom you can understand what is the present condition or what is the present position of the shaft. Position means angular position. Definitely we are talking of an angular position because this is a rotating element. Alright, so this is how it works. Now you see here that the type of servo that we are using, this is a conventional analog servo motor. It is always, when it is in operation, it expects to receive the pulses. You can tell it roughly after every 20 milliseconds. So that means that we have to apply a 50 hertz signal. So you can see here that for 0 degree position, this duration of pulse and space, it should be 20 millisecond definitely. But for 0 degree position, it is 1 millisecond pulse is required. For 90 degree position, you can find 1.5 millisecond pulse is required, and for 80 degree position, you can find 2 millisecond pulse is required. So it is one shot of PWM that we have to apply to the control pin of the servo motor to rotate the servo. Now you see here that we can definitely apply such sort of signal through any digital pin of the Arduino, and you can drive a servo. However, one good thing is that the servo element, it has got a dedicated library. Therefore, the coding part becomes very simple. However, you can definitely use a library to run any device. You can read any sensor or you can run any actuator, but you must be able to understand the basic operation. So here you can see, and you have to remember this thing, that it should be a 20 millisecond time period for the pulse width and the space width. For 0 degree position, it should be 1 millisecond pulse width, and for 180 degree position, it should be 2 millisecond pulse width. Definitely you can vary the pulse width so that you can achieve different angular positions. Okay. Now you see, this is the basic pinout where typically the servos have these 3 color coded wires. The brown wire is for ground, the red wire is for 5-volt connection, and the yellow wire is the control wire. It can be the color of orange or yellow. Okay, so this you have to remember, because accordingly you have to connect the servo to the Arduino. Again, for this figure we are indebted to Last Minute Engineers. Now you see that if you are using a micro servo motor, then you can directly power it from the Arduino board. However, remember that if you are trying to drive a servo that is having a higher power, that it is a high torque servo, then you need to add an additional power supply. You have to take help of that because the Arduino will be loaded otherwise. Now see that I have written here that if you are using a high torque servo that requires a heavy power, you need a capacitor of a large value, normally 1000 microfarad, that works good. It should be connected between 5 volt and the ground, otherwise the Arduino might get reset because of the startup. During the startup it will be drawing heavy current, so there will be a problem. Normally there is a problem of getting the reset of Arduino board, that is unwanted reset, therefore such a capacitor is used. So that we will not use here because we are using a micro servo. Now you see, let us try to understand this servo library is there, because this operating a servo is a tricky one. But as I have told you, there is nothing to be very worried about. You can simply make some of the digital pins high for 1 millisecond, and you can give a delay of 19 milliseconds. So what does that mean? That means that you are ultimately applying, and then you have to again give that 1 millisecond pulse. So the thing is that under that circumstances, what you have to do, you have to make one of the digital pins low initially, then you have to make it high, keep it high for, you can see here, you can keep it high for 1 millisecond, then make it low, maintain that low status for another 19 milliseconds, again make it high, keep it high for 1 millisecond, then come back for low again. So that will make one step for the servo. Its position will be fixed at 0 degree. So this is how you can do. But we are very fortunate that this Arduino, they have got a very tactfully designed library. So whenever you are using a library, you can see here that you have to include that in the program. So you can see here that this hash should be there, include within these greater than and lesser than signals, there should be servo.h. Once you write such a statement, that means that you have included this library. Next, you have to declare the pin of Arduino that will be used to control the servo. Here we have used servo pin 9. So this is the statement, servo pin. Okay. So you have to declare that. Next, you have to create a servo object in which you have to write servo. This you have to do. You cannot change it. Next, if suppose you have 2 servo motors or 3 servo motors, accordingly you can write servo 1, servo 2, like that. Then you can simply use int angle is equal to the value at which you want the servo to be rotated. That's pretty simple. Now, in the setup function, we have to link the servo object to the pin. So we will write servo.attach within bracket servo pin. So you can see this attach. So we have linked the thing. Okay. And finally, you have to write servo.right angle. That's it. So we will get directly into the program. This is the circuit. You can see there they have used a 5 or 6 volt adapter they can use, because they are using maybe a higher power motor, and that can be connected to external adapter. You can definitely, I have told you that you kindly visit the lastminuteengineers.com to have a very detailed discussion on these topics. You can see that the servo signal is given to Arduino Uno pin number 9. Servo pin is connected, that is servo voltage pin is connected to Uno pin number 5 volt pin, and servo ground is connected to Uno ground pin. So initially we will be doing this experiment where we will be simply rotating the servo, and then we will be adding one pot to the servo, potentiometer. Okay, so the simple thing is that servo will be connected as we had already discussed above, and the potentiometer will be connected in a manner that one left terminal or right terminal of the potentiometer, one of the terminals will be connected to 5 volt, the other extreme end terminal, if the right terminal is connected to 5 volt, the left terminal should be connected to ground, and the center terminal or the wiper terminal should be connected to one of the analog inputs, because our main aim will be to rotate the potentiometer so that the analog pin reads some voltage, and that voltage we have to map to some angle. Whatever voltage is developed, so we develop actually here as per the at the output of the ADC 0 to 1023. So that we have to map. We can map it like this: 0 to 1023, that means 0 comma 1023 comma 0 comma 180 or 170 or 160. So that means at one condition of the potentiometer, one extreme condition of the potentiometer, the servo will be at 0 position, 0 degree rotation position, and if we rotate it for another extreme, that will rotate by the degree that you give. It can be 90 degree, it can be 180 degree, it can be 170 degree, anything. Okay, so that will be the mapping function that we have already discussed in our earlier discussions. So this is all, and we will directly now, what we will do, we will be directly going to the program. For that, you may please find, I will be showing you this vision. You can see here, this is the servo. Just I have connected a small sticker so that we can follow the rotation of the shaft. Let us see what we have done. You can see here, these are the 3 pins from the servo. You can see here, and that have been taken through a junction. This is nothing but a junction we have made, and you may easily find that there are 3 pins in which you can see here that this ground pin, the ground pin is connected to ground. As we know, the brown pin is the ground pin. We have connected it here. Next comes the yellow pin. You can see here, this yellow pin is connected to pin number 9. You can see here pin number 9. As you may find, if you open, that this pin number 9, it's actually a PWM pin. So while using this servo library, be careful that you have to connect this servo to some of the pins that is enabled with PWM output. So this is very important point that you must be considerate about. So we have connected to pin number 9 here. Now you see that this input for the servo, this is the orange pin, that is input for the servo. This I am connected to one terminal of the breadboard. Now we will be giving a 5 volt supply to the same line of the breadboard where we have connected the supply pin of Arduino. So you can see that's the same line. So Arduino is getting 5 volt from this green wire. Now you see this potentiometer, you can see from this side. I will be opening it. The potentiometer, it is having 3 wires connected to it: the red wire, the black wire, and the brown wire. Okay, so the shaft or the wiper is connected to ground wire. So we will be getting the voltage, continuously varying voltage, when we rotate the shaft across that ground terminal. So therefore you can see here, this is the brown terminal of the potentiometer. This is the brown terminal, that is, you can see it is coming from the potentiometer, that we will be connecting to analog pin A0. Alright, so we'll connect it here. We have connected it to analog pin A0. The one extreme end, that is, there are 3 terminals of the potentiometer. The center terminal is connected to analog input. The other terminal, one extreme terminal, is connected to 5 volt. You can see here, this green pin is connected to 5 volt, and you can find this red and this orange pin, they are already connected to 5 volt right now. So it is ensured that the servo is getting the 5 volt supply, and the potentiometer is also getting the 5 volt signal. Now you see the ground, this black wire, it is connected to the opposite end of the potentiometer, to which the 5 volt supply is there. So this black is connected to ground. You can see it is connected to ground. So this very simple circuit we have prepared, and now we will be going for the program. So I will be opening the Uno. I will again connect this indicator, otherwise it is so small now, it will be very hard to be followed. So we will open this Arduino, and we will get into the program. So I will open, because I have already kept the programs ready. You can see this is the basic servo program. Yeah, so you can see here the brown wire is connected to ground, red wire is connected to VCC, yellow wire is the control wire. This is just for our reference, and that's why you have seen that this slash is given, rems are given, so that they are not counted into the program. Then initially you can see that we have included the servo library. Now you may be a bit surprised that where does the library come from. You can see over here, you can see in the sketch there are several libraries. You can go for manage library. So whenever you are going for this library now, there are several libraries already included in the Arduino IDE, and several libraries are further available. So just you need to remain online, and for particular module, or if you are going through some project that you have to develop after going into this YouTube, many times what happens that we do not include that particular library. So therefore we can simply go to the sketch, we can go for include library, we can go for manage library. You can see that there are so many libraries that is already given. You can see servo is already there. Okay, so servo we have included hash include servo, then servo pin is declared, it is pin number 9 for Arduino side, then servo is there. We have given the angle to be 0, so this is our initial angle, this is 0. Now in the setup part, we have attached the servo to the servo pin, and then we can see the loop part which will be continuously happening. So what we will do, we will try to develop a program. You can see we have used the for loop, angle 0, and angle will keep on increasing till it is 180, and we have to write to the servo the value of angle. So in order to give the servo for its rotation command, you have to go for this right, and you can see this angle is there. We will have a delay of 15 millisecond. Remember here, this 15 millisecond is very important because it is within that 20. Okay, that 20 millisecond time period, pulse width plus space width duration. Next, after that, once it reaches this 180, initial angle again we will take 180, and we will rotate up to 0 degree, and this will happen when the angle continuously keeps on increasing, and it will be updating to the servo. Again we have to use a delay here. So here we started with 0, we went up to 180, then we started 180 at 180, and we went up to 0. So this is all. So what we can expect with this program, the shaft of the servo motor, it will be rotating continuously between two extremes of 0 and 180. So let us go for that. We will compile. We will upload. Okay, where servo is not connected, so I will connect it. So we have compiled again, and we will upload. So let us now get into the camera view. So you can see here the shaft is rotating continuously in 0 to 180 degree. So we can be very sure here we can change the values, or we can write some value of angle so that it can rotate that way. That is also possible. Okay, so now let us move to the second part of the program. That's quite interesting, in which you will find that maybe I'll be using a light. I don't know whether this light will be required. Okay, fine. So it's all about this operation. Now we will move forward to the second part of the program, another program. So let's get to Arduino. I will open another program. This is in order to control the rotation of the servo with the help of a pot. So you can see here, this is the program. Again, this is also very simple. You can see here we have included the servo library. Then the potentiometer pin, it is connected to A0 that we have declared, and we have declared the pin to which the servo control pin is connected, that is pin number 9. Then that servo, this is a compulsory function that you have to follow. Then there is voice setup. In the setup part, we have attached the servo pin, and then initial angle has been declared to be 0. And then there is the loop part, where you see we are reading the value of the pot pin. So you can see here the reading is given. So the reading is a variable. So we are getting it, this analog read function pot pin. So whatever voltage, the central pin of the potentiometer is reading, that is stored in this variable reading. Now I will be defining the angle, so for which the map function has been used. The reading is the thing that we have to map. The reading we know, minimum value is 0, the maximum value is 1023 because we are applying 5 volt to the pot. So the complete rotation of the potentiometer shaft will be giving 0 on one extreme and 1023 value on the other extreme, because we are reading the value out of the microcontroller ADC. So that value has to be mapped in between 0 to 180. So when the potentiometer will be rotated externally, then the motor shaft will have a rotation from 0 to 180. And finally, we have to write the value of this angle to the servo. We have to give a delay of 15 milliseconds. So this is all about this program. Let us compile the program, and we will upload the program, and let's go for the camera vision here. Let us see here. We are rotating this pot, and you can find the servo is being slowly rotated. It is simply following the pot. While you are performing the experiment, you will find some false rotation of the potentiometer also. It may develop a feeling in you that I am rotating the pot, why the servo is not rotating. So you can see that we are mapping two values that are having much difference, So at 0 it creates a problem. So you are actually trying to 0 to 1023, you are making it 0 to 180. So some part of the potentiometer rotation will be giving no yield or no result. Afterwards you will start getting rotation from the servo. You can see here, now I am giving a clockwise rotation of the pot, and you can see the servo follows it very closely. Now you can see this is the false. Some part of the potentiometer gives a false motion. Now you can see again, I am going a bit faster. Okay, so this is all about controlling the servo. For any of your confusions, kindly comment in the comment box so that we can get back to you with the solution. Thank you.